Bias versus variance in AI. Bias versus variance in AI. Beginner level. Introduction. Artificial intelligence. AI. Models learn patterns from training data to make predictions. However, sometimes models make errors because they are either too simple or too sensitive to the data. Two important concepts used to understand these errors are bias, variance. These concepts help explain why machine learning models make mistakes and how to improve their performance. Understanding bias and variance is essential for building accurate and reliable AI models. What is bias in AI? Bias refers to the error caused by overly simple assumptions in a machine learning model. In simple words, bias equals the model is too simple to capture the true pattern in the data. Example concept. Dataset means simple model means incorrect pattern learning. When a model has high bias, it fails to learn important relationships in the data. This often leads to underfitting. Example of bias. Consider predicting exam scores using study hours. Dataset. Study hours score 240, 460, 680. If the model assumes that study hours do not affect scores, it will make poor predictions. Example concept. Model ignores relationship means inaccurate predictions. This is an example of high bias. Signs of high bias. Indicators of high bias include overly simple models, low training accuracy, low testing accuracy, failure to capture patterns. Example concept. Training accuracy low means testing accuracy low. High bias often results in underfitting. What is variance in AI? Variance refers to the error caused when a model becomes too sensitive to training data. In simple words, variance equals the model learns the training data too closely. Example concept. Training data means overly complex model means unstable predictions. A model with high variance performs well on training data but poorly on new data. This often leads to overfitting. Example of variance. Imagine a model trained to recognize cats in images. If the model memorizes specific training images, it may fail to recognize new cat images. Example concept. Training images memorized means poor recognition of new images. This is an example of high variance. Signs of high variance. Indicators of high variance include very high training accuracy, low testing accuracy, complex models with many parameters, sensitivity to small data changes. Example concept. Training accuracy high means testing accuracy low. High variance usually results in overfitting. Bias versus variance comparison. Concept description. Bias error due to overly simple model. Variance error due to overly complex model. Related problem underfitting. Related problem overfitting. These two errors represent different types of learning problems. The bias-variance trade-off. In machine learning, there is often a balance between bias and variance. Example concept. Too simple model means high bias. Too complex model means high variance. The goal is to find a model that balances both errors. Example concept. Balanced model means good training performance means good testing performance. This balance is known as the bias-variance trade-off. Example illustration. 3 model behaviors. Model type behavior. High bias too simple. Misses patterns. High variance too complex. Memorizes data. Balanced model learns true patterns. Example concept. Balanced complexity means accurate predictions. Good AI models aim for this balance. How to reduce bias. Bias can be reduced by increasing model complexity, adding more features, improving training algorithms, increasing training time. Example concept. More learning capacity means better pattern capture. How to reduce variance. Variance can be reduced by increasing dataset size, simplifying the model, using regularization, using cross-validation. Example concept. Better generalization means stable predictions. Example Python concept. Example machine learning model. From sklearn. Linear_model import linear regression. Libraries like scikit-learn allow developers to adjust model parameters to balance bias and variance. Real-world applications. Bias and variance are important in many AI systems. Image recognition. Models must avoid memorizing training images. Financial forecasting. Balanced models capture trends without reacting to noise. Recommendation systems. Systems must generalize user behavior patterns effectively. Concepts learned from bias versus variance. Understanding these concepts helps beginners learn. Checkmark why machine learning models make errors. Checkmark how model complexity affects predictions. Checkmark how to improve model performance. Bias and variance are fundamental ideas in machine learning theory. Simple definitions. Bias. Error caused by overly simple assumptions in a machine learning model. Variance. Error caused by a model being too sensitive to training data. Final summary. Bias and variance are two major sources of error in machine learning models. High bias occurs when a model is too simple and fails to capture patterns in data, while high variance occurs when a model learns training data too closely and fails to generalize to new data. The goal of machine learning is to balance these two errors through the bias-variance tradeoff. Achieving this balance leads to AI models that perform well on both training data and new unseen data. Understanding bias and variance is essential for anyone learning artificial intelligence, machine learning, and data science.